So I'll call this video 6.3 Investigation Follow-Up, just so that you have an explanation as to why you did this investigation. I'm just trying to find a new color here. Let's go with this one. So the first set of equations that you were given, y equals 2x plus 3, y equals x plus 3, y equals 1 half x plus 3, y equals 0x plus 3, y equals negative 2x plus 3, y equals negative x plus 3, and y equals negative 1 half x plus 3 are all graphed right here for you. All 7 equations. So I did the first one in the first example. Here's the answers, which I posted as well for the rest. Okay. And then you were asked some questions. Well, let me show you the other graphs too, just to make sure. So the second set of equations were y equals 2x plus 5, y equals 2x plus 3, y equals 2x plus 1, y equals 2x minus 5, y equals 2x minus 3, and y equals 2x minus 1. Again, there's all your equations nicely graphed and laid out for you. You were asked some questions way back on page 5 of your notebook. Question number 2 said, compare the graphs in each set. How are they the same? How are they different? So looking at this first set, how are all of the graphs the same? Well, they're the same because they all cross this point on the y-axis. I'm making this big enough so that I can erase it later. They all cross that point on the y-axis, and that point on the y-axis is, let me get this bigger, this point right here has coordinates 0, negative 3, or 0, 3. Okay. This point right here. Okay. Now, what does that tell us? So that's what's same about all of those graphs. What's different about all of those graphs? Well, the difference is, so there's that point again. The difference is, well, look at all the lines. They all go in different directions. Some are positive, some are negative. And we would say that the difference would be they all have different slopes. So how are they the same? They all cross at the same point. How are they different? They all have different slopes. Now if we look at the equations of each individual graph, let me go way back. Let me go way back to 6.3 in the notebook here. So 6.3 right here, looking at the first set, knowing that we can look at those graphs and we see they all cross at the same point, we can ask ourselves, well, what's the same about all of these equations? Well, the same thing in all of these equations is that they all have this plus 3. So you should be able to infer, deduce, decide, come up with the solution that, well, this number eventually, or tells us where this line crosses the y-axis. And that point has special coordinates of 0, y, whatever that value happens to be. And we call it the Y-intercept, where a graph crosses the y-axis. What's different about all of these equations? Well, the difference with all of these equations is this number that comes out in front of the x. The 1 half, the 0, the 2, the negative 2, the negative x, or not the negative x, sorry. This negative sign, which I'll come back to in a second, and it's negative 1 half. And we have this one here. There's nothing out in front of this x, but remember, there's always a 1 there that we never write. And just like here, there's always a 1 there that we never write. So what's different over here? Well, the difference is a negative 1. So the difference with each of these equations is that number in front of the x. And what did we say that was different about all the different graphs? They all had different slopes. So this thing that comes in front of the x tells us the slope of the line. This thing over here, the rest of the equation, tells us the y-intercept. And looking at the second set of equations, we could do this. We could answer that same question. We know what the graphs look like. They're all parallel lines. What's the same about them? Well, they're all parallel. They all have the same slope. And again, what's the same about the equations? This number out in front of the x. These are all the same. this tells us the slope of our line. What was different about all of those graphs in that second set? Well, they all cross the y-axis. Well, let me go back and have a quick look. They all cross the y-axis at different places. It's coming. There it is. See how they all cross the y-axis at different places. This equation is here, this one's 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 here. What's different about all of the equations? Well, this value here and here and so on and so on and so on, which I'll look at when we go back there. Just let me try and erase these here without wrecking all my pretty lines. So let's go back, have a look. This back and forth thing's not very good, is it? Have a look at these equations here. What's the same about them all? Well, they all have that same number in front of the x. What's different about them all? Well, they all have this part being different. And what was different in our graphs? Well, they all cross the y-axis at different places. So again, this tells us our y-intercept. What was the next question? Number 3, determine the slope of each line. Well, in our first set of equations, if you were to determine the slope of each line by looking at the points and counting rise over run, or picking 2 points and calculating values, whichever way you did it, you would find that the slope of each of these lines would equal the value that comes in front of the x. This one being -1, this one being +1, and this one obviously being 0, which gives us what kind of a line? A horizontal line. Okay, 0 slope is a horizontal line. Now, what's the same about the equations, or what's the slope of all the equations of the second one, or the graphs of the second one? Well, if you were to calculate the slope of any of those 5 or 6 different lines, you would find that the slope would be equal to 2. Didn't matter which one you chose. So that's question number 3. Determine the slope of each line. And 4, compare the slopes with the corresponding equations. What do you notice? Well, I noticed that as I calculated the slope of each of these equations, whoops, eraser, each of these equations, that it happened to match the value, ooh, that's too big, happened to match the value here, match the value here, match the value here, and here, and this -1, and this +1 that we never write, and the 0. Over here, you would have noticed that the slopes calculated for each of the lines was exactly the same and happened to be this value right in front of the x. Question 5. What did you notice about the y-intercept? What did you notice about where those graphs crossed the y-axis? So back to our first set, looking at the graph, you would notice that they all cross the y-axis at the same place. That place happened to be right at 3. And what's same about all of these equations? Well, they all have this +3. On the second set, you would have noticed they all cross the y-axis at different places. What's different about all of these equations? Well, all of these parts of the equation. So you need to be able to look at the information that you graphed. You need to be able to infer some information. But bottom line, what should you have gotten out of this exercise? Well, after doing the equation, or the questions that are noted at the bottom, what should you have gotten out of this exercise? So I'm going to go way back down to my graphs again, just because I've got way more room to work with down there. And I'll tell you what you should have gotten. Looking at our first set of graphs here, all these fancy lines that go in a number of different directions, you should have been able to recognize, and you should now be able to recognize, that if you are given an equation, let's make this nice dark color. If you are given an equation, y equals mx plus b. I say m because I know this is slope. And I'm calling this b because we actually call this the y-intercept, b. If you're given an equation in this format, this b thing is our y-intercept, the place where it crosses the y-axis. How do I know that? Well, that's the same. The y-axis intercept, this y-intercept is the same for all of these equations. And all of these equations have this plus 3, and so on and so on, plus 3, plus 3, plus 3. Okay? So that's what you should have been able to infer. Looking at the second set of graphs, again, given this form of the equation, mx plus b, knowing that this is the slope already, m, you can look at these equations, look at these graphs, and know, well, they all have the same slope. Well, what's the same about all of these equations? Well, this 2 that comes in front of the x. So you now should be able to say that this definitely is the slope of an equation. So now we have what we call the slope y-intercept form of an equation of a line, or for an equation of a line.